Okay, and we're back into example 2.7 now. We're flying through these. Only one more to go after this. So example 2.7. Let's get it going. So you see here that I have a force P of 950 newtons, and it's applied to a body along the slope. And we want to resolve this force into its rectangular components. It didn't draw it for us this time, but you know that's just the x component. We can call that px. And the y component, py, which just turns this into a triangle problem. It also doesn't give us our angles. We can calculate them if we want to, but all we need to remember is that this right here, that's the ratio. So 5 to 12 will be the same as py over px. We know that already. It tells us that from the beginning. So if we can find out that third component, we can use our ratios to solve everything else. We don't have to worry about using any sort of trig functions. So let's do that first. I'm actually going to do it completely different than how the problem is set up. And let's just solve our slope triangle to begin with. So, well, I need to find that last component, 5, 12 here. So I'll do that. I know from a Pythagorean theorem that c will be equal to a squared plus b squared. And all the square root of that. So that'll be equal to the square root of 144 plus 25. Which will equal the square root of 169, which is equal to 13. So that right there is 13. Okay. Good to know. Also, this 5, 12, 13 thing, it's a very common slope triangle. It'd be good to memorize that just to save yourself some time. Now then, whatever ratio I want to use, I can use it to solve. So if I want to solve for the x one, well, p, there we go. Px to p will be the same as 12 to 13 because they're on the same sides. So 12 over 13 is going to be equal to px over p. I don't have to do any trig whatsoever. I just use those ratios. It's going to be the same ratio. The horizontal to the hypotenuse is the same as the horizontal to the hypotenuse. We're done. I know what p is. So I plug that in, what I'll get is it's 877 pounds. It's going to be exactly the same. You can see I'm doing the same thing right here. That's just 13 right there. Okay, now for py, once again, I do a very similar thing. It's just a ratio. So I'll get rid of everything else. And I know that 5 to 13, okay, is going to be equal to py over 950, which if I solve it, it comes out to be 365 pounds, which makes sense. 5 over 13 is a much smaller fraction than 12 over 13. I would expect it to be a much smaller number. So do those kind of, mental checks when you're doing these problems. If the numbers don't seem to make sense, if you're worried about it, probably not good. Now, I know you don't have necessarily a lot of engineering experience yet, so when these numbers might not seem too crazy. But if you look at a fraction, it's a big fraction, and this is supposed to be similar, you would expect a bigger number. Also, if we're doing it visually, which you can't always do because not all of my examples are drawn to scale, you see that this side is much longer than this side, and so it should be a bigger number. Okay, well, that is everything. So I hope this helps you, and I'll see you all next time as we do the last example for chapter 2. Bye-bye.